Okay, guys, welcome to Human-Computer Interaction class. We will be doing 14 weeks course together, focusing on usability, human-computer interaction, and user interface design. And during the class, my chat window is open. So if you have any questions and comments, or if I ask any questions, feel free to write to the chat box on the right side of your screen, or sometimes it's at the bottom, I don't know. On my screen, it is on the right side. So the purpose of technology. Why do we have to use computers? Why do we have to use technology? Is an interesting question because as a humankind, we want to have better living spaces, better eating possibilities, enjoyment from the life and education. So anything better is sought, asked for. Therefore, human changes the world. When human changes the world, the tools are usually later named as technology. So the purpose of the technology to enhance the quality of life, human life, it's an interesting subject. For example, after the first industrial revolution, the world population started to increase faster because nutrition was possible. People were able to feed themselves with more industrially produced food, wheat, etc. So population increased. Therefore, the technology is for human, not for technology itself. On the right side, we see a television receiver. Here we have a mirror. We have a mirror here, and there is a tube at the bottom. So this is a TV receiver from 1939. So it was like a furniture in the typical home, American home. So today we have much different technology named as television. The same television here, people were watching it like if they went to cinema. So the topic of man-machine interaction starting 1940s when people started focusing military and civil airplane design, cockpit design, because the performance of pilots and bombers did not increase, even though the quality of fighting equipment increased. The success rate of the armies did not. So they focused on why our soldiers were not able to quote, kill more other soldiers. The result was the human performance. So performance of the soldiers, performance of the pilots did not improve because of the interaction issues. And again, complex weapons were difficult to use, and if the weapon is difficult to use, then the success rate dropped significantly. So they focused on usability of weapons. And then after the Second World War, industrial equipment and house appliances, computers and automotive interaction issues are considered as important and played important role in sales and use of the goods and services through house appliances, through computers and automotive, etc. Every day we hear accident news. This is one of the examples. Most of the driver errors are actually interaction errors, usability errors, because no one wants to make errors. So when you make an error, when you make a mistake, it is by mistake. So you don't want it. One of them was a recycling plant. The guy was going to clean the tank, and another guy started the device. So the guy was inside the tank and got killed. So who was responsible now? Are they responsible? Are the workers responsible? It is basically the engineer who developed the device is actually responsible, because you have to design engines, you have to design machinery so that the use of the machinery, the usage protocol, usage mechanism of the machinery will not allow such accidents. Okay. Again, this is another airplane accident. Happened a few years ago. Inside the plane, there was a physics professor who was working on CERN research center, and she was also my professor when I was undergraduate in the university. The idea is that the pilot said, I am going down. So he believed that he was landing properly, but actually he couldn't. So it's probably attributed as pilot mistake, but at the end, pilot doesn't want to make mistakes. If mistakes happen, but it is the system that should prevent those mistakes from happening. So this is a motivation for the class. So not only nice looking, pleasing interfaces are important, but also life-threatening data loss and other significant results, significant consequences can happen. This is another Air France. When human-computer interaction is when human-computer interaction is concerned, usually airplanes are given as important examples, because airplanes are expensive and very well worked systems, because they should not fail. They should stay on air and they should not fall down, and the errors should be minimized. So airplane interfaces are nice examples of well-worked human-computer interaction devices. Let me bring up the screen. Are you seeing unfortunate news or the picture of the Air France?
Unfortunate news you're seeing.
But both of them are unfortunate news. But is it Turkish or is it English?
Dev kazanda korkunç ölüm.
Okay, okay. I'm trying to change it. Let me change it. Okay, this time I think it's done. This is another example. This is again several years ago. It is blamed on the pilot, and all 228 people got killed when traveling from France to Brazil, I think. The issue was pilot was thinking that the plane was going down, but the devices were saying that plane was going up. So pilot, second pilot and first pilot and third pilot had a dispute. It was night. Had a dispute that whether they are going down or up. The first pilot thought they were going down, and then he tried to climb up back, but actually they were going up, and at the end they went up to the very steep direction and then fall down backwards because it was too high. That was another device believability issue. Devices were saying something, but you don't believe it, and you think something else, and you make mistakes. Actually, it is not mistake, but the believability of the device. This one has been given in human-computer interaction books in 1992. Again, France. It was an accident in France. You see, there is a 2.8 here. Here you have 2.8. This 2.8 means either 2.8 degrees or 2,800 feet per minute. Depending on depending on the display here. Here it says either VS or FPA. If it says FPA like this, it means 2.8 degrees. If it says VS, it means vertical speed. And that is set by I think this knob. So it's a double position knob, either VS or FPA. If it was an FPA, then you think that you are descending with a 2.8 degrees angle when the system automatically adjusts itself. Or if it is VS mode, the rate of deceleration is set. The reason of the accident was pilot was thinking that it was in 2.8 degrees mode, but actually the display was in 2800 feet per minute mode. So it was in different mode, but this is what we call mode error. And the plane got crashed because he couldn't figure out which mode he was in.
On the website bbc.co.uk, they say the mode is the number that appears the most. 1. To find the mode, order the number.
Hey Google, stop.
And see which number appears the most.
Google Home is present. So this is the display. This is the VS FPA switch. And they make investigation after the accident and make laboratory tests. And during the laboratory tests, people failed to distinguish between two modes. And after the design, they replaced all the displays in Airbus planes. So all the displays were replaced, indicating that they should have 4 digits instead of 2 digits. So they added 2 more digits. So if it was 2.8 degrees, it was displaying 2.8. If it was 2800, it was displaying 2800. So previously it was displaying 2.8, but you should map it in your brain as if it was 2800. So that resulted in an error. So this was another interesting accident information. This is an interesting device. Paper cutter. Can I run it? No, I can't. So you have 2 buttons here. In order to operate, there is a very sharp knife there for cutting the papers. In order to operate this device, you have to press, after the adjustment, you have to press 2 different buttons at the same time, simultaneously. The reason is that you need to put your hands away from the knife, because otherwise you cannot press those buttons. Those buttons are positioned in different places unless you are 2 people. So this is to eliminate the possible accidents, and it's a very effective solution. See, yeah. So you don't cut your fingers. Well, actually, there is an increase in technology. This is time. This is complexity. And this is the evolution of the human capability. So human capability does not increase as fast as the technology. So this soldier and this soldier are usually similar soldiers, not very different. Maybe early soldiers, medieval soldiers, were stronger than today's soldiers because of the natural selection, because weak ones did not survive. However, performance of the equipment is million times more advanced as of today. So there is an problem matching the capabilities of the new tools and devices to the human performance. At the beginning, these are from trains. This is Spitfire. Second World War airplane. So at the beginning, you say that if it works, okay, don't touch it. And you make devices, you build tools, industrial equipment, big vehicles, trains, etc. But the operation becomes difficult because human factor is disregarded. Human factor is disregarded. Another nice example. Same brand. There are two auto radios, same brand. The purpose is to listen to the radio, listen to the news, whatever. But the number of controls increased significantly. So when number of controls, number of things to control in our life increase, it creates problems. So there are too many variables. Those variables must be understood by the users and must be responded, etc. If there are no variables, you don't have to control. But if there are variables, you may need to control. Therefore, that brings the design problem of the user interface. So when we pass technical threshold, technical limitations, and the designers realized that the system performance did not increase, then human machine interaction ergonomics became important during 1940s and 1950s. Man-machine interaction and the word ergonomics came out for the factories at the beginning. The term ergonomics, let's go back to definition. The term ergonomics is the application of scientific information concerning objects, systems, and environment for human use. So objects, systems, and environment relations for human use is the topic of ergonomics. Traditionally, it is thought of as how companies design tasks, work areas. This is important because it makes money for the companies. Work areas and machinery to maximize the efficiency and quality of the employee work. So it is mostly regarded something related to factories, but actually it moved back to houses, automotive, and computers and office environment as well. So ergonomics, therefore, comes into everything which involves people. In some cases, we have the definition as software ergonomics. So software ergonomics also used as a keyword in the research area and engineering area. Human-computer interaction is interesting. Recent term is UX. UX. What is DX? DX is used for digital transformation, the buzzword. UX is user experience, buzzword. But actually, a more scientific and engineering term is the human-computer interaction. It is a discipline concerned with the design, evaluation, and implementation of interactive computing systems for human use. Keep in mind that it is the design, evaluation, and implementation. So all of the three parts are included in HCI, not only the design. So it is not, when we talk about human-computer interaction, we don't only deal with the design, we also implement, or we also evaluate the existing products and services for human use. Ergonomics are HCI are related. Ergonomics is more considered as a physical part, and where HCI is considered as more cognitive part, but actually HCI involves both. If there is computer, it's HCI. If it's a tool like scissors, etc., although same principles, some similar principles are available, valid, we call them ergonomics. So ergonomics of the watch, ergonomics of the mug, etc. When consumer appliances are becoming interactive and supported with microprocessors, etc., then HCI and ergonomics are mixed, because it's a device. For example, it's a kitchen device with microprocessor. So HCI and ergonomics should go together, or in the automotive design and the automotive car design and the cockpit design, etc. Ergonomics and computer interaction goes together. Any questions so far?
Everything is clear until now, sir.
Okay. So at the beginning, as I said at the beginning, number of variables is not much. So you have a washing machine and you have to wash and dry, that's it. So there is an on-off button. And later 60s, there is a cartridge here, program cartridge. You insert the cartridge and the behavior of the washing machine changes. So it is kind of front-loading, programmable, but the program cartridges are different. So cartridges include hardwired circuit inside. So when you replace the circuit, the behavior changes. The computer is not available. It is all electronic and circuit based, sometimes mechanical. But later, you have a display and a knob, interaction device, and buttons in each side. So too many variables to control, and understanding becomes difficult. Also, it becomes a new task to design such interaction scenarios. In future, more and more devices can have such complex variables to control. Although recent trend, I'm going to talk about it later, although recent trend is to hide this from the user, and if you make the machine intelligent, the machine will decide what to do using artificial intelligence or fuzzy logic, etc. The system will decide what is the best scenario rather than asking everything to user. We see that in a lot of coffee machines, some coffee or telephones, some coffee machines have very complex buttons, or the washing machines as well, but very expensive ones started dropping complex user interfaces. Rather, they have very few selectable menus because they realized that users are not interested in those variables that much, and it makes more harm than good to make those variables available for controlling. In the East, Japan, Korea, and maybe China as well, complex controls are considered as higher quality. So when you go to Japan, interaction with more variables is considered as a positive thing. In the European design or American Anglo-Saxon design, they started leaving it for the engineers. End users don't like that much control. It is not regarded as a quality indicator. So a typical example from the Japanese washing machine. So as you see, aside from the language, it was too many. There were too many different controls. Each variable is controlled with different push buttons, and which is interesting. So it's also a cultural issue. So that's a mechanical TV, and I think the screen is here. Very small. This is the bigger screen. Consumer appliances are interesting area for the human-computer interaction research. Instead of interaction, we sometimes use the word usability, kullanılabilirlik in Turkish. We call the term usability, and it also includes appliances of everyday objects, and equipment in our daily lives. So then the concepts are now applicable to broader sense, not only for computer screens, but also for daily appliances and devices include usability issues. Also the traffic management, the traffic signs, the roads, the buildings, design of the houses, design of the school, design of the table, the kitchen, design of the office, everything now becomes related to usability, and many principles are actually the same in those designs. So after this class, you start realizing certain problems in your daily life, even though they are not directly related to computer interaction. It's a traffic sign, but the position and the placement and the shape of the traffic sign, for example, conflicts with the theory, and then you realize that many people are failing to understand that traffic sign because of certain problems, well-known problems. Screen is a new thing. In 1959, nice, this is an advertisement from the magazine. There is a computer. The computer is here. This is the control panel of the computer. There's the input device, but the output device, there's no output device. There's no screen. Input device and output device is usually, for the modern ones, are typewriters. So you use typewriters to input the code, and output is also printed to the paper in those years. And the working area is the whiteboard. So the scratch area, instead of screen, you use the whiteboard. Today, it's changed. You may have multiple screens. For example, now I am having multiple screens. One of them is used for presentation. Another is used to interact with you guys, and it works fine. And you may have more screens to interact with, and that creates cognitive load. Too many information. So each of them contains a serious amount of information. So this guy may have problems understanding the information and responding to proper events. These guys also had challenging problems. The problems were also significant, but they were using paper and pencil, and they were holding those variables in their head. They were simulating. They were simulating the variables in their head much more than this guy. This guy has the variables there. Previously, these guys usually assume certain things as certain values. So it was more difficult. If similar problems were more difficult in the previous years. So having multiple screens, more information, actually have some overload issues, design problems, but actually it makes your life better. So it makes you solve more problems. You can solve more problems with it. Why it is so important? Many products are similar. So when you go to the market and search for the phone to buy, many phones are similar. Many Android phones are similar, so iOS are similar. But the difference becomes with the look, other users' experience, user performance and satisfaction of your friends, etc. Two different things remain here. Brand, which is built up with the others, and advertisement. So if you exclude those two, also this is related to usability, but let's say it's an old brand, famous brand, so it can consume the name of the brand for several years until it dies. But external look, other users' remorse, and the performance of satisfaction is important. For example, in terms of brand, the famous example is Motorola. It was a Motorola. It was a famous brand, but it couldn't keep up with the recent user interface and technology with the digital phones. In the digital phone area, it was very famous analog company and chip making company. Today, the chip maker is named as NXP. It was famous for the processors, industrial processors, microprocessors. But the telecommunication device of the Motorola and the phone maker of Motorola went down very fast. And so brand recognition is no more there because of the other issues, because of the challenges in usability and challenges in product quality, etc. in late 1997. Again, this is a TV receiver from 1938. This is the screen. When we have good interfaces, iPod, original, the project development is improved. People like it. Training costs lowered. People will use it in deeper level. More functions will be used. So if more functions are used, they will be more happy, and therefore sales increase. And with the better interfaces, training is required. Users get frustrated, they get bored, and data loss happen. And at the end, they may stop using the appliance and some feature they say they don't need it. They don't need that feature, but actually the actual reason is they don't know how to use it. So nobody thinks that they are difficult to use or they can't use. They say they don't need to use, they're not interested simply because it was difficult. Or they are frightened to make mistake or make a damage using that feature. So if they are frustrated, they stop using that feature. We have typical examples from the past. Windows güvenlik duvarı başarıyla açıldı means firewall is turned on. Here you have close. So if it is in English, there is no problem here. But when you translate with an incorrect, when you use incorrect translations and the keywords together, and the command keywords together, then it creates a problem. So this is an açıldı and there is a kapat here. So they conflict. This is very important. So when user clicks here, you never know whether firewall remained open, active, or inactive because it says kapat here. So this should have tamam, or this part aktive edildi. Something like that will solve the issue here. So aç and kapa is an antagonist word and shouldn't conflict with the dialogue, for example. Another one, this used to be İş Bankası internet banking application screen. Today it is not available anymore. It's all changed. But this is like 10 years ago, and I cut it for a very serious example. And you go to the menu and apply for the internet banking. You fill your phone number and TC number, name, and submit. After you click submit button, this screen comes. After you click submit button, this screen comes. And what you read here is, thank you. The first thing you see is the thank you. When you see thank you, you think that finished. You believe that your task is finished. However, you have a long form here, another form here, another form here, another form here, and at the last form, you have another submit. Okay? So this was ridiculously incorrect. And what could be the solution at that time? This much information is too much. They don't read it. So write one sentence in a dialogue format and then put some button to continue. Don't let people think that the task is finished. So any clue that the task is finished, people want to finish tasks. So any clue that resembles something is finished must be avoided if task is not finished. So teşekkür ederiz here is a word that is said at the last time and temasa geçeceklerdir, etc. So you believe that somebody is going to call you and you don't read it. It says her forumun sonunda bulunan devam, forward and backward. Use backward and forward. And at the end you say you should press submit, etc. So it's too complicated. Nobody can do it. Okay, good enough. When we focus user interfaces, many of the user interfaces are used in real life, not in home, single user, single office environment. So the user interfaces are used in different settings, and when you are designing the user interface, we need to consider the environment, the interaction between two pairs. You can ask questions, for example, see what's happening, or some feedback is shared between the workers. There is an attention demand here. So this attention demand affects user. The performance changes. There are different papers here. There are T, calculator, and screen. So many things are on the desk space, and they are related. So they interact, and the customer asks question, etc. So interrupts the task, asks for another person comes and asks another thing. So user interface should recognize, should consider these events and environment, because many problems can arise through these secondary entities. This was another banking setup when we were working with the bank. There is a calculator here, phone here, the screen, and keyboard, and the customer is here, and there is a money counting machine here on the left. So all of them are connected. Sometimes they are connected, sometimes not. But the attention of the worker is connected. It is not only the computer that affects the job performance. So later in this course, we will, before giving the break, we will go through human-computer interaction fundamentals, goals, human sensing capabilities, vision, hearing, and motor systems. We will discuss the Fitts law. We will go over the memory, human memory, the capacity of the memory, and the memory-related issues with the human-computer interaction. And then we will go through the different parts of the interaction. So the first, vision, hearing, and motor, and then the memory, short-term memory, long-term memory, and mental models, etc. Then we will move on to general guidelines in the interface design and out-of-box experience and disability issues, and etc. And some homeworks will be given. The homeworks will usually be design homeworks or interface building homeworks.
Hocam syllabus'ı yayınlayacak mısınız? İşte final yüzdesi, vize yüzdesi, ödev sayısı.
Evet. Onu, I will give them in the class page. So additional topics. Among the additional topics, we will have usability laboratories, web design, mobile, and house appliances. So interface evaluation, prototyping software, which you may have homework with, and task analysis. So in order to develop a good user interface, you need to understand and analyze the task. That is one of the topics that we are going to cover. Yeah. And usually 10% class participation, 20% homeworks, 30% midterm, 40% final. So usually this is class, this is homework. Yeah. Usually this is the case. Starting this semester, I will give more importance to class participation. So attendance will be taken, and attendance will count almost 10% of the grade, year grade. So let me get the attendance then. Okay. Let's give a break for about 10 minutes and come back at okay.
Okay, so we'll see you in 10 minutes.
Uh-huh.